Thanks, Marco. Hi, everyone. Right, I'm Rolo. I'm going to be talking about using machine learning to generate music. My code background, I've been programming since I was small, working in Python for 9 years now. My first time speaking at PYCON. I've been running a consultancy called Wildfish for 16 years. We build Python web apps, mostly with Django. This is just, the machine learning stuff is just a pet project of mine, but I'll make you stare at the logo for a few seconds. And my music background, I've been DJing on and off for 15 years. It's mostly off since having kids, playing various styles of trance through the years. So trance, hard trance, but these days it's mostly psychedelic trance. I've dabbled in music production for a similar amount of time, and I've been playing piano for about a year, which has broadened my horizons a little bit and is great fun. I very much recommend it. So I don't even know if I need to say this, but just to be clear, the stuff we're generating here is going to be MIDI note data, so there's no audio coming out of this. MIDI files are just sequences of note data. Every note on the piano keyboard has a different number, and the music I'm into is trance and psytrance, which tends to be quite short themes, and so in some ways I guess that makes this problem a little bit easier, but the main reason I'm doing that is because that just happens to be what I'm into. So I'll walk you through how to do this. Bit of maths. I guess I don't need to explain that, no? Not really. This is a linear algebra free talk. I found that this is really good for getting practical experience with machine learning and then filling in the theory afterwards, because you can be using it to get results. So to get started, there's this project from the Google Brain guys called Magenta. So Google Brain, the people that make TensorFlow, and it's an open source project for generating music and art. They provide you a load of different models for different things. There's one for generating sketches, one for generating drum tracks, one for image stylization, and it kind of seems like it's a bit of an experiment in progress from the Google Brain people. So they provide a load of different pre-trained models to get started very quickly, and there's a Docker image, but the easiest way for Python people to get going with this is just pip install Magenta, or Magenta-GPU if you've got a TensorFlow enabled graphics card. We're going to be using the Melody RNN model, which is for generating MIDI data, and we're going to be training our own model rather than using the pre-provided ones. So the first thing you do is create a note sequences file. This is a format that Magenta uses internally in lots of different places. It's a Google serialization standard called a protocol buffer. You point it at a directory of MIDI files, it processes them and puts them into this note sequence file. It will butcher one, it will ignore ones that are a bit too short or a bit too long or don't have enough notes in. I've butchered Magenta a little bit to work with shorter melodies because that's more suitable for what I'm doing, and dance music riffs tend to be quite short. Then we take our note sequences file and turn it into a sequence example dataset. This is what Magenta is going to be using to train on. Here you have this config parameter, which tells Magenta which type of config model you want to use. There's three that come provided. There's one called basic, which just uses the last note in the sequence to predict the next one. And then there's one called lookback RNN, which will look back over the last two bars of the tune to decide what to do next. And then there's one called attention RNN, which is based on this paper someone wrote in 2014, which gives each of the previous notes in the sequence an attention score. The idea being that this will then create melodies with more long-term structure. You give it an eval ratio. This is just the percentage of data you want to keep back for training versus evaluation. And it defaults to 10%. I've had some success with raising that a little bit. And we run our training. You need to use the same config parameter as we did in the last step. So we're using attention RNN. And there's some hyperparameters here that you can play with. These are mostly undocumented, but I found that they can make a big difference to things. The ATTN length is how many notes back you want the algorithm to look when it's taking into account what to play next. And the dropout keep probability is for the probability of dropout. Dropout is this idea when you're training a neural network where you just throw away some of the data with a random percentage, which sounds counterintuitive, but is something that's really helpful for avoiding overfitting. And that's a problem that you'll run into a lot with in lots of different machine learning algorithms. But in particular here, it can be really frustrating because you'll generate a melody and listen to it and think that sounds brilliant, and then you realise it's just ripped off one of the ones from the training set. The learning rate is it's a standard machine learning thing for how quickly it's going to make adjustments, and you can tweak the RNN layer sizes. I've found that not to have a massive meaningful difference to the results, but it does make the training more likely to crash. This will give you a training accuracy score starting at 0 and approaching 100 as it becomes more confident in being able to make predictions. You can run this command with another parameter called eval if you want to look at TensorBoard and inspect the network. I've not really found a lot of value in doing that, but you can if you want. And then this is the command to generate some melodies. Melody RNN generate. You have to use the same config and hyperparameters as you did in the last step, or strange things happen. And the only other things of note here, number of outputs is how many files you want it to generate. Number of steps is how long you want them to be. I'm working with fairly short themes, but other people do compose really long things. Temperature is something you can tweak to make it not follow the model so rigidly. It kind of introduces a bit of randomness. And then you have a primer melody, which is the note that you want it to start on. So 61 is the MIDI data note for middle C. But you can also give it a short sequence of MIDI data, or point it at a MIDI file, and it will try and finish things off for you. I mentioned overfitting, so I'll just quickly mention this. Before coming up here, I was very mindful that I didn't want to be demoing stuff that had ripped anything off from our training sets. So one of our guys, Jonas Hagstead, built this tool called MIDI grep. You point it at a directory of MIDI files and give it a sequence of notes, and it will tell you if that sequence occurs anywhere within the directory. So I'll play you some examples now. So these are the first three. I didn't know whether I should just play you the MIDI note data, which would sound kind of raw but be a bit probably more representative of what's being generated, or if I should put some synth on it, which would make it sound a bit more impressive. So I went with the latter, so it doesn't sound rubbish. So these are just, well, I'll play them to you. So that was off of the lookback RNN. You can hear there's some kind of, it feels to me like there's some meaningful structure to the melody. It kind of resolves in a satisfying way. And then this one I put a slightly meaner synth on to give you a different sort of idea. And then the last one, this was an attention RNN one. So I think that these are the best examples I've come up with so far, and something that there's other people approaching this problem, and there's other startups generating music, and something that is worth knowing when someone's generating it is how many different melodies they've had to come up with to give you this. So just to give you an idea, the second two I generated last week off of my current model, and I probably generated maybe 50 or 60 melodies, and they were the best two. The other one was quite some time ago, and I'd probably say that's the best one that I've managed so far. So typically speaking, I'd get it to generate maybe 10 or 20 and then flick through them, and half will be complete rubbish, a few will be, that sounds okay, and then you get the odd one that sounds like it's really good. But the results seem to be improving all the time. So another great thing about this, which is undocumented, is seeing the reaction you get from people when you tell them that you're doing this, because it's very different to how we normally approach creativity. So I'm going to talk a little bit about creativity and think about whether this counts as creativity, and if it doesn't, what would. So if you ever talk philosophy with anyone on the internet, you just end up arguing about definitions. So we'll start with what is creativity. three definitions there, the Oxford English Dictionary, Wikipedia, and Mumford, who is an American psychologist who writes about creativity. So they all kind of say it's about coming up with something new and useful. So we'll keep that in mind as we're thinking about this. And I was interested in the history of creativity as well. So I looked back at how people used to see creativity, and apparently, this surprised me a bit, the ancient cultures in ancient Greece, China and India all saw creativity as a process of discovery rather than creation. This is a quote from Plato's Republic. Will we serve a painter that he makes something? Certainly not, he merely imitates. So thinking about it in that way kind of turned it on its head a little bit for me, thinking that there's these melodies out there and they exist and I'm discovering them, kind of like trying to, I guess, someone's Bitcoin private key or something. So I looked at the kind of state space of the melodies. Could we get infinite monkeys to come out with melodies and provide something useful? And as you can see, it grows exponentially. This doesn't take into account different timings and rhythms. This is just for a sequence of notes. As you can see there, for a 10 note melody, you've got 75 billion. So you're unlikely to just land on one, but an order of magnitude more likely than guessing someone's Bitcoin private key. And thinking about, say, the 75 million 10 note melodies in there, I was thinking, does anyone ever hear their favourite one in their lifetime? Will I hear mine? Does anyone? Can we ever prove that? And there's something quite exciting about thinking that. So this is what human creativity looks like when I'm composing anyway. And you spend a lifetime listening to music to find examples of what you like. Then I'll jam around on a keyboard till I make something that I like the sound of. And I think that if we look at what the machine's doing, this is the XKCD about machine learning, you stir the data till it sounds right. I sort of think that's in some ways not that different to jamming around on the keyboard until you find something that sounds right. And then I see this training process as kind of analogous as spending your lifetime listening to music and deciding what you like. You get this accuracy score that starts at 0 and approaches 100. I'm thinking an accuracy score of 10%, you have tastes where you kind of listen to what your parents play in the car, and then 50% you might go to our price and buy your own CDs, and at 90% you're becoming a fully fledged music snob and you know what you like. And then, but then I happened across this page of notes. This is from a friend of mine called Mawlabaux, who's doing a master's in music composition at Guildhall University. So he's a proper musician by any stretch. And I don't know if you can see that, but he's looking at the relationships between the frequencies to help him compose. So he's using maths from the outset rather than this kind of trial and error approach. And from talking to him, he put me onto computer assisted composition, which is a thing. This is a book by a guy called Yanis Xenakis, and he would use mathematical models to assist him when he was composing music. And he'd actually do that on the computer as well. And then I wondered about other examples of non-human creativity. So this painting wasn't made by a human, it wasn't made by a computer either. This was made by a monkey called Congo in the 1950s. Apparently Congo was very deliberate about how he worked. If you gave him a painting and he felt like he wasn't finished, he wouldn't stop. Or if he thought he was done, he wouldn't go back to it no matter how much you could coax him into it. And some of his paintings sold at auction for $25,000 in 2005. Apparently animal art was a bit of a thing for a while. We've had dolphins and elephants that can paint. It's hard to know how deliberate this is. And there's a rabbit called Beanie that you can find on YouTube that likes to paint. And the other thing that this made me think about is, who's the artist here? Is it the monkey or the person? And I think with Congo, it's the monkey. When we've got really clever AI models that can compose music, then is the artist the person or the computer? And that put me onto this picture. This is called the monkey selfie. So this monkey took this picture itself. In 2008, a guy called David Slater went to Indonesia with his camera kit and befriended a group of wild monkeys. He left his camera set up, and then one of the monkeys ended up taking a load of pictures, including this monkey selfie. So he licensed these pictures to a news agency and made a book about them, and it turned into this giant copyright row because a monkey can't hold copyright over something, so they ended up going to court and settled, and they had to make a settlement to pay monkey charities 25% of the profits from this book. So I wonder what will happen there with, I guess a computer can't hold copyright, but it seems pretty definite that a monkey can't at the moment. And then back to our computer composer. I'm thinking about, when you have some new technology, sometimes you have a period of time where you're just trying to make it as good as the thing it's replacing, but I think what's exciting about this is the future of where this could go. I see no reason why we couldn't have instruments that can compose for you, so maybe you'll have a keyboard where you can play a melody and it will finish it off for you. I mean, the tech to do that is already there. It's not going to be awesome, but it will work. And then I thought we might get off-the-shelf pre-trained models based on different styles. So if you wanted a classical model, you could buy it in a shrink-wrap box, which is an oddity of this future, and then it will generate for you. But I think probably the most practical thing, and I expect we'll see this in our lifetimes, is totally one-off, unique performances tailored to you. So rather than your smartphone going and finding music that it thinks you'll like on Spotify or Google Play based on what you've listened to, it will be able to compose stuff on the spot for you. And then imagining maybe you'll be in a club, we've all got we've got these fitness trackers and so on, we're getting metrics off of our bodies now about whether we like stuff or not. Maybe you'll be in a club and then the music will be being written for you on the spot, tailored to exactly what you like. So, does this count as creativity then? Intuitively, I want to scream no, I don't think so, but if we look at our definitions again, imagination or original ideas to create something new. I don't think there's imagination happening here, but it's imagination or original ideas. I think there's original ideas. Something new and valuable is formed, yep, but definitely. The production of novel, useful products. So, I think either this is creativity or we need to change our definition. So thank you. I've got some examples I'm going to put on SoundCloud. I'm going to be a little bit more methodical about it now that I'm starting to get decent results, and I'll be listing the parameters I'm using, and this has been improving over the time I've been working on it, so I don't see any reason why it can't keep on getting better. And and I think if nothing else, it's an interesting puzzle to play with and solve, so please feel free to have a go and play around with Magenta yourself, and come and find me if you want to compare notes or chat about it. Thank you.
Is it done? Yeah. So we have a lot of time for questions. Gentle reminder, is question time. So if it's not a question, you can talk with Rolo later. Is he here?
Yeah, sorry. Hi, thanks for the talk. It was really great. Those samples were also very, very interesting. I was wondering, in terms of parameters, what would be the difference? Because the first one you showed us, it reminded me of it gave me a Minecraft feeling. But the other ones are very appropriate for clubs and parties and.
So the first one, unfortunately, happened kind of almost, I wouldn't say by accident, but I was much less methodical in my approach when I was doing that. So I remember it was the lookback RNN I was using. I expect I probably didn't tweak the other parameters too much because I was fairly new to it. But the data you're using is very important. So unfortunately, I don't have the exact parameters for reproducing that one. The second one, I can tell you, were trained on only about 2,000 MIDI files. They're all trance files. I'm finding that I'm getting better results with small data sets because I want stuff that's exactly what I like. You could just use one of the pre-trained Google ones that's trained on about 50,000 MIDIs. That was using the attention RNN with an attention parameter of 20. So I've been working on that model for a little while now. In preparation for this talk, I wanted to try and find some good examples. But I feel a little bit like I've hit a dead end with that. So there's some newer stuff that Magenta's doing now. There's another couple of new models, and I think I'll probably play with them next and then maybe go back to lookback RNN if not. But I think from seeing that there seems to be value in this approach, I'm going to approach it a lot more methodically, and I don't see any reason why the results won't keep on improving.
Thanks.
Other questions? Okay. One here.
Where do you get your training data sets from?
So I just had a load of MIDI files anyway from playing with music production, but you can download, there's sites that just have MIDI files archived. Something that I'd like to do is it's increased the size of my training data set. Back in the day, before we had digital DJing of Traktor, I had a giant spreadsheet with a list of all my CDs and what tracks they were. So one of my next projects is going to be to write a bot that will trawl the internet to find MIDIs for all of those, and then I'll have a lot more data to train on. But I expect when I start getting good results, I'll be able to feed the good results back into the training data as well, and then it should just keep improving.
Yeah. You said you used MIDI grep to see if there was overfitting.
Yeah.
But is there any way to tell maybe it's just the same but moves to a different key? Maybe that could be a problem.
Yeah, I'm sure that's something we could make MIDI grep do, but it's not something it does at the moment. So I guess that is possible. But I wonder how much you'd see that in real music anyway. I expect there'd be quite a lot of times where you'd see stuff that is another tune in another key. I mean, in pop, it's very frequent for melodies to be reused and so on. I think it's probably a little bit more obvious in dance music, but I'm not sure.
Any other question at the back?
I have like more psychological question. What about the joy of making music and sharing it to the other people?
Yeah, look, this is a great question, and this is a discussion I've had in lots of different places. But I think for me at the moment it feels like a puzzle to solve, and I don't know if this will turn into an approach that I'd use instead of writing my own music. Maybe it would, but I think that the thing for me is I'm quite intrigued as to why I even care about music. Why does this sequence of notes and their ratios make me feel anything at all? And so I want to explore why that is, and this seems like it's a path to understanding all of that better.
It's not about that you have... I believe that the musicians have like a joy in creating this music.
Right, yeah.
Right? So when they are sharing, the people can feel that emotion put into that.
Gotcha.
So that's why some of the hits, like I don't know, Ed Sheeran is like being sold so fast, right?
Mm-hmm. Right. Okay. So yeah. So what you're saying is the computer can't have this emotion, but I think for me, and for programmers, there's a joy in these sorts of puzzles as well, aren't there? So maybe that novelty will wear off. But what I'm wondering is the emotion that I like encoded into the music in some mathematical way? So eventually, if this gets good enough, will the algorithm start making stuff that does have my emotions in it because I've given it enough examples of what counts as my emotions and what moves me? And I don't know what the answer to that's going to be. Maybe it will, maybe it won't.
One more question? Anyone?
Are you finding that your outputs have some kind of recurrent loop? Like, do you ever produce some notes that just get stuck on the same 3 or 4?
Yep, sometimes. Sometimes, I don't know what it's doing. There'll just be a big gap, or it'll just play one note and then nothing. Or sometimes, yeah, it will just loop between 2 notes. And I wish I could ask it what it was thinking, but... And yeah, and as I said, you get an awful lot of rubbish. So, I wouldn't demo this live to you. I wouldn't write the command to generate 10 melodies to impress you all, because 6 of them would be awful.
Last one?
So do you think, using this kind of a network for generation, that if it does start coming up with good stuff, will you be able to understand what it's abstracted away for you to learn from?
I'm not sure. I'm intrigued to find out. I think it will certainly give us more information in that direction to help us understand it, but the short answer is I don't know for sure. I'd love it if it could. I'd love it if there was a way of, I don't know, somehow documenting or having some sort of metric for what some people like and some other people don't like, because there must be some sort of science to this. It just seems like it's so hard to comprehend, because it's emotions and music, and it seems almost magical, but there must be some maths behind it.
Thank you. That was very interesting. Please.